number 3, it's like a product into a quotient into a chain rule.
It's like that movie Inception. Let's see.
Yeah, that's how you.
It's a product, it's a quotient, and a chain and a chain.
Yeah.
Double chain.
Double chains, a product and a quotient.
Right, so I did the product on top. Now I'm confused on what to do.
We'll do this one in the tutorial for sure.
Okay. It will show off.
Also, I just do it again,
I
but
was
now
so
as opposed to.
one in the night because I found the tea.
You were high. Let's be serious here.
I was so hyper. All of us were
I don't know that happens here. It sounds so bad. Oh my god.
Was this frustrating to type out?
Yes. Took a while to put this book together. I think we'll start the next one now. Frustrated? I don't know why everyone is jumping to number 3.
This is the most difficult one.
It is easy.
Did anyone finish it?
Possible, see?
Can I see your answer?
No, it just
No, you can do it later because I'm about to start the next lesson now. So,
€50.
alright. So, we'll start the next lesson now. Implicit differentiation. Can you all turn around this way? Might be better for you. Don't knock
I feel like the computer is good.
Yeah, living dangerously. Right, that's alright, isn't it? I think so. Ahmed, do you mind closing the back door there? It swung open, it's a little bright. And also a little cold.
It smells like smoke.
Huh?
It smells like smoke. Like
I
smoke.
think what happens is people who are in those classes come outside to smoke. Great.
What? I got smell it.
Okay, we'll start now. Guys, we'll start now. So, we're looking at implicit differentiation in the next lesson. This question is related to the circle, which is something on the Charles exam, which we'll talk about maybe separately in a different class. So, you can kind of not worry about question 1 in the book anyways. You can just start from number 2. So here's the idea. Suppose I had a problem like this, and I said x squared plus y squared equals 1. And I ask you to find dy dx. Well, one problem is that you have to rearrange to make y the subject, because you don't actually have y yet. So you could say y squared equals 1 minus x squared, and y equals plus or minus root 1 minus x squared, and y equals plus or minus root, plus or minus 1 minus x squared power a half. Now we can actually find dy dx. So, what rule do we need here? We would need the chain rule. That's plus or minus there. So it's plus or minus a half, 1 minus x squared minus a half, and then multiplied by minus 2x. Now, of course, that's a little bit difficult, and you realise if the problem is even just a little bit harder, it becomes nearly impossible to do. So, for example, if I said to you, something like x squared plus x plus y squared plus y plus 1 equals to 0 is very, very, very difficult to make y the subject here. It's not impossible, but it's actually very, very difficult. So the reason these questions are so difficult is because the x and the y, they're not separated. They're tied up together. They're on the same side, whereas they should be y equals. So we have a way of calculating this more quickly using something called an implicit derivative. So I'll show you what that is now in a second. Once you have that, we can scroll down.
Guilty.
Can you see okay? Yeah. Can I scroll down? Will I scroll down a little bit so you can see the bottom? Is this okay? Question? No? Yep.
Are we going to solve this?
Oh yeah, we'll do this one as an example. Once I give you the theory idea.
Can't you just change the y's to u or something?
It will
Doesn't
still
really
be the
take away
same.
the problem of having them mixed on one side. But it is kind of like this. There is a chain rule that you can use here.
You make it like x.
Well, we'll have a look now. So, on the side here, if I asked you, here's y squared, what's its derivative? I said derivative of y squared is not 2y. It's not. Now, I'll give you a simple example to show you why this is wrong. So, for example, imagine I said y is equal to x. Keep it simple. Then what is y squared equal to? X squared. And then the derivative of y squared would equal 2x.
Yeah.
Oh, sorry, this is a stupid example because by sheer dumb luck it actually is equal to 2y.
Yeah.
So yeah, no, that's a bad one. I'll need to make it at least a little bit harder. So let's say I have y cubed, and I'm telling you that the derivative is not 3y squared. And the example is, we'll say y is equal to x squared. Okay, make it a little bit more than just y equals x. So if y equals x squared, what does y cubed equal? That would be x 6. And so the derivative of y cubed, that would be 6x 5. And that is not the same thing as 3y squared. Because what would 3y squared be? That would be 3x 4. And you got 6x 5. You don't need to write this down if you don't want to. I'm just trying to give you an example to show you why the derivative of y cubed is not simply 3y squared. It's not quite as straightforward as that. Okay? But it's not too difficult to get it. If I can go back up a little bit here and just go to the side here for a moment. So, if I want the derivative of something like y cubed, the trick is I put here a dy
Cube it.
not that, and actually not as hard as that. So I put in a dy because dy over dy, what's that? It's 1. And then I swap the denominators because they're being multiplied. So that's dy over dx, and then this is dy. Now this guy is actually okay. The reason it didn't work earlier is because this variable is y, and this guy is x. It's the wrong match. Whereas now this guy is y, and this guy is y. So the answer will be dy dx 3y squared. So actually we have a very, very simple rule. If you want to differentiate a y, just do it like normal, but multiply your answer by dy dx. So here's some small examples. So if I said sine y, what's the derivative? The answer would be cos y dy dx. If I said ey, its derivative, ey
dy
dy dx. You get the idea here? If I said y squared, its derivative would be 2y dy dx. And if I said y, its derivative,
dy dx.
1 dy dx. Or in other words, no surprise, dy dx. Okay, so this is what is called an implicit derivative. And the reason it's called implicit is because there was no need to separate the y. And you don't quite have a, although you have an answer, you don't have the answer in terms of x. But it's useful for calculating with these problems. So I'll go back to the main question now in a second. Yeah, okay.
So when you take dy dx, you're just saying
You can ask me again once the question is fully formed in your head, okay?
The derivative.
Wait, is it fully there?
It's there.
Okay,
it's
go
just
on.
not coming out. The derivative of the y, of the equation,
Yeah.
times the derivative of y cubed. Is that what you're saying?
I don't know what you're saying,
I
but
don't. I'm not sure of this.
let me go back. Guys, look up. This is what I'm saying. If you have some function of y, for example, y cubed, and you want to get the derivative, so you want the derivative here. Well, let me just be clearer. You want the x derivative here. What you do is you differentiate, pretending y is like x, like a normal function, and then all you have to do to compensate for the fact that it's a y function and not an x function is just multiply your answer by dy dx. Okay, that's all. So y becomes 3y squared, and you compensate for it being a y and not an x by simply multiplying your answer by dy dx. That's all. That's all it is. So it's just very similar to what we've done, except you just multiply your answer by dy dx. That's all. Nothing crazy. So let's go back to our example we had here.
And dy dx would be the derivative of
Well,
the
just-
function.
Let's see with this example, okay? Let's see with this example.
Okay.
Might answer your question. So here, I want the derivative. So what I do is I differentiate every term, starting from the left, going to the right. So x squared becomes 2x. X becomes 1. Y squared becomes 2y dy dx. Y becomes dy dx. 1 becomes 0 and 0 becomes 0, so this is just equal 0 still. Now remember what I said. I'm looking for dy dx. So I need to rewrite this to get dy dx. So I have 2y dy dx plus dy dx equals minus 2x minus 1. Now, dy dx is in common. I can factor it out. So 2y plus 1 dy dx equals minus 2x minus 1. So now I'm finished if I divide. minus 2x minus 1 over 2y plus 1, that's dy dx. The only problem, it's not really a big problem, is that my final answer is in terms of x and y. This means in the question, if I asked you to find dy dx at a point, like x equals 2, you need to also know what the y value is as well, which can either be given to you in the question or you can find it from the original. Now we'll do that in a second. I'll give you one to try, not so difficult. Can I scroll down?
Yes.
Have you seen this one before?
Yeah, but it was different. Like, you'd have to square everything.
Square everything?
Yeah.
Are you
like
sure?
You put it into a y squared function and square everything.
No, I'm not liking the sound of this. Are you sure?
Yeah.
Question? Yeah.
Like, you take the highest power, put it in terms of the highest power, and then square, and then
What?
take it across everything.
Oh no, I need to see this. This is.
something close to that or something. Maybe
need
I'm
to-
misremembering. I don't know.
Yeah, something sounds fishy there.
This was
All right,
8 years ago, so.
fair enough. Can I scroll down? Yeah. Okay. So look, I'll give you one to try. I want you to find dy dx of x squared plus y squared minus, no, equals 169 when x is 5 and y is 12. Try that for me. You got an answer there on the back, guys? Did the three of you know who Larry, Curly, and Mo are?
Yes.
You do know those three? Okay. Well done. Well done. That's not a relevant point to anything, by the way. Yeah. Are you finished? The three? No, I'm just worried about those three. They're making lots of action in the corner. Finished?
Which three?
Wild guess.
It's classic. Classic. Yeah. The answer could be, I think it's a fraction.
Yeah.
Yeah. Is it like 12 over 5 or something?
Minus 5.
5 over minus 5 over.
Minus 5 over 12, was it? Okay. Are you downward sloping? Yeah. Okay. Let's have a look here at this one now. So we implicitly differentiate. So x squared becomes 2x and y squared becomes 2y
dy.
dy dx. And that's equal to 0.
Yeah.
Cancel the 2's. Bring the x to the left. It becomes minus x. And then divide by y. So you get dy dx is minus x over y.
Yes.
And we know the x,
Minus
12. And we 5. And we know the y,
12.
12. So that's the answer then. So what on earth went wrong down the back there? Or did you get this?
No, I didn't get it.
You didn't get it.
Yeah,
You got it?
me too.
You got it or didn't?
I got
Good job. Yeah.
What's the 169 for?
The 169, you didn't have to use it for this one. But it is important because if x is 5 and y is 12, if you sub it into this, it must be on this curve, so it must be true. 5 squared plus 12 squared is 169. Now, the 169 will become more important for the next example I'm doing. Okay. But you are right. The 169 wasn't necessary for getting the answer here, but it was still part of the equation. Can I scroll down? Yeah. Right. Find dy dx of x squared plus xy plus y squared equals, let me think what I want to make it, 12, where, or when, I should say, x is 2. Now, there'll be 2 answers, so I just want you to take the answer and also we'll say y is, no, screw it, give me both answers. There's 2 answers for dy dx.
You'd have to find y first.
You don't have to do it first, but you do have to do it eventually.
Yeah.
Yeah.
You got it down the back, guys?
it.
No. Huh? Who's saying it's wrong? You believe him? Got it?
Values of the
Got
nearly,
it?
How do you find y? Like because because like you have a squared, so like it's always gonna be in terms of y.
substitute y.
Yeah, I did substitute.
Excellent.
And what then? I did. So then what?
Quadratic.
Yeah.
Oh. Okay. Right.
That thing again. Oh, it's just not going away. All right, let's have a look now, guys.
2 minutes.
Well, look. Okay, all right.
I just need to find the. Two times 2, 4. Like minus 4. 1 second, 1 second.
You substitute for x then?
Yeah. Yes. 1 second, 1 second.
Okay. Got it.
You got the y. You got the dy dx?
Yeah.
Great. Angela?
Yeah. Yeah.
Guys, we're going to have a look now anyways, okay?
Substitute 2.
So, the first thing we need to do is we should figure out what the y is. Guys, listen. Angela, listen. So, first thing we need to do is figure out what the y is. And we can do that by subbing in the x into this. So, if I sub x in, I'll get 4 plus 2y plus y squared equals 12. So, I'll get y squared plus 2y minus 8 equals 0. So, I'll get y minus 2. The heck? Yeah, that's weird. Thank you, Ahmed.
This is gonna get slam.
Yeah, we'll just wait a sec. Boom. All right. Minus 4 and minus 2, isn't it?
Minus 2 and plus 2.
No, one of them's a plus.
Plus 4.
Plus 4 and minus 2. Guys, don't talk when I'm talking or I'll eject you painfully. Okay? Right. Equals 0. So we get y equals minus 4 or 2. Yeah? So that means we're actually looking at 2 points. 2 minus 4 or 2, 2. Okay. Let's differentiate implicitly. So x squared becomes
2x.
2x. Now, I wonder how many people spotted what we have to do next. Product rule, yeah. So that's 1y plus x dy dx. Is that right? Plus 2y dy dx equals 0. You can rearrange that and you'll get dy dx equals minus 2x minus y over x plus 2y. And then we sub in our 2 points to get the 2 answers. So let's see, I'll put in the first one, I'll put in 2, 2 first, it'll be easier. So 2, 2 first, and then 2 minus 4. So 2, 2 first. I'll do this one first and this one second. Right. That would be minus 4 minus 2 is minus 6. 6 over 2 plus 4 is it's a minus 1. Did I do that right? Minus 4 minus 2 is minus 6. 2 plus 4 is 6. Minus 6 over 6 is minus 1. Now I'll put in this one, 2 minus 4. So that's minus 4... 0, is it? Minus 4 minus minus 4. Yeah, it's 0. So they're the two answers. So what that actually tells me is what's special about point B? What's so special about point B?
It's like
No?
Sad.
What is it? Center.
Zero.
Ah, guys, come on.
it's with
Hang on. Everyone stop for a second, right? No, stop for a second.
30 points.
Listen. Just take a moment to say to yourself, I'm not an idiot. I know this. The derivative is 0 means we have a
30 points.
minimum or maximum or a turning point, a stationary point. Okay? And so that's the B. The A is -1, so what's happening at this point? What's the graph doing at this point? It's decreasing. Okay? So whatever shape this graph is, it's a minimum or maximum at B, and it's going down at A. Okay? This is semester 1 stuff. Right, I'll give you one more example here to try once you have this written down. Yeah. Got that? Can I scroll down? Yeah, okay. Right. Let's do this one. Y equals 2 power x, and we want the derivative here. So, the reason I'm doing this one is because we don't have a rule from semester 1 for how to calculate, how to calculate the derivative here. But we can use implicit derivatives to help us. The first thing we want to do is get that x out of the way. It's in the power, it's inconvenient. Because usually the x isn't in the power. So what I'll do is I'll log both sides. So that's log y equals log 2x. Now what can I do with the x? I can bring it down. Now I can implicit differentiate. So log y becomes 1 over y dy dx. Now be careful here. What will x log 2 become when I differentiate it? Be careful. No. No.
Log 2
No.
is constant.
Log 2, the constant.
Oh yes.
Because this is just a constant by x. You know, if I said what's the derivative of 5x, you would say 5. If I said what's the derivative of log 2x, you would say log 2. Log 2 is just a number. About 0.7 or something. So, we get dy dx equals y log 2. But what is y? Well, we're told it was 2 power x log 2. So I've differentiated 2 power x. The derivative of 2 power x is 2 power x log 2. Now, I've seen this one in the exam a few times. So, it's worth writing this one down carefully.
I don't understand how you went from x log 2
How I went from where?
x log 2.
I differentiated.
Yeah, but
What's the derivative of kx? It's k. So in this case the log 2 is like the k. Okay, let's see what happens. X log 2. So what's the derivative of x? 1 log 2. And then it's x And what's the derivative of log 2? 0. So the answer is log 2. Yeah.
So we have to substitute the value, but we have to show that we have substituted the value.
The y back in, yeah. So guys, sometimes in the exam they might ask you to show something. So they could say, show that if y equals 2 power x, the derivative is 2x log 2. However, if this was part of a bigger question, they don't necessarily need you to show this. You can actually use the result. So the result is, if you have something like a power x, its derivative is a power x log a. Now, the special case is if it's e power x, what would that become? E power x log e. But what's log e? It's 1. So the derivative of e power x is e power x. But you can use this as a result in a question that is not asking you to prove it. So you're allowed to use that as a known result. The only catch is that it's not in the formula book, but if you know it, you can use it. Yeah? Yeah? What's wrong with him? What's wrong, Amjad? What's wrong? Convince me. What's wrong? All right. Actually, there is one more example I want to do, but not a particularly long one. Can I scroll down? Okay. So, x squared plus y squared equals 25. Find the x dy at 3, 4. Did you get an answer? What you got?
Minus 3.
Minus 3 over.
4 over 3 or minus 4? Minus 4 over 3? What did you get over here?
Minus 3 over.
3 over 4.
Well, one of you is right. Which one though? So, derivative here is 2x plus 2y dy dx equals 0. So that means dy dx equals minus x over y. So that means dx dy equals
God.
minus y over
I
x.
get
dx over
I knew
Yeah,
it was
yeah,
zero.
ah,
I knew it was
snap.
Oh.
I warned you about this in the first semester. You need to watch out for it when they do this in the exam.
Your x and your y look the same.
Yeah, but if you were listening to me, I said dx dy. Did you get it?
I did
Ah, you
too.
didn't
Minus
get
3
it.
over 4.
Mo, did you get it?
No.
No,
Yeah.
we're the Brazilian
I
ones.
didn't notice the DX there.
Yeah.
I did think it was weird that you'd ask such an easy one.
Yeah, you should have
It
been.
was so weird.
You should have been suspicious.
It's tricky. You should have ordered yourself.
Yes, valuable advice.
So
Yeah.
so you can put such tricky question in the exam.
Yeah, that's why I've asked it now twice, because they've done this in the exam at least once. And I think a total of 0 students noticed this in the exam. Well, young Pang, this is why I'm doing it in class. So at least now there's a chance that you'll spot this in the exam if it comes up again. So I don't think anybody in the exam got the last step. Everybody missed the reciprocal, the flip. Yeah. Yeah. That little bit of pain you feel right now is what will help you remember this in the exam.
This is very weird. It's DX, D1,
The meaning of it is, what you're doing, young Pang, is you're looking at x. It's almost like you've swapped the x and the y around. So it's like x here and y here. So you've switched the axis, and you're looking at how x changes compared to y.
X is dependent.
Yeah, you're making x independent and y dependent. I said that backwards. Y independent, x dependent. Yeah. Yeah.
So if X was time, no.
But another meaning of it is like this. You know dy dx, what does that represent? That represents the slope of the tangent, right?
Yes.
So then minus dx dy, what would that represent? The line perpendicular to the tangent, which is called the normal. So there is actually a reason for wanting dx dy, because it could give you the slope of the normal, whereas dy dx would give you the slope of the tangent. So my point is, young Peng, they're not just doing this to be jerks. There is a valid reason for wanting dx dy. What? Okay. Now, let's see. Yeah, these are all pretty good exam style questions. The one I will tell you that catches students out. Most students answer these questions quite well in the exam, like 2 to 11 is answered quite well. What really catches people out in the exam is number 12. This really catches people out in the exam is number 12. So, if anything, please, whatever questions you pick to practice, I think it would be a good idea if you make sure to practice number 12. Alright? Okay, just try 1 or 2 for a minute or 2 and then we'll finish. Okay, so just try 1 or 2 questions there. Can I close this? Yeah?